All right, welcome back, guys. Today is going to be over 10.2 polygons and quadrilaterals. So earlier we talked about triangles and all their traits and everything else. And now we're going on to figures with more than three sides, essentially. So I already have it all written out here. You can pause the video and copy that down. But essentially, I'll just go through it. Polygon is a closed plane figure. If it's regular, it means that all the sides are equal. If it's convex, it means a segment joining any two points are always inside the polygon. So for example, if I have here, just some random shape to get from here to here, or from here to here, or from here to here, I have to stay inside or on the line of the polygon. However, if it was something like a star, notice I can get from here to here, and I'm on the outside of the polygon. So this would be considered concave because of the little cave that it makes here. This shape would be considered convex. Okay, so that's the difference with those. And then a diagonal is a segment that joins two non-adjacent vertices. So this is a diagonal, that's a diagonal in that case. All right, so again, these would be polygons. Now this one would be considered concave because I can draw on the outside to get to connect two vertices. This one, however, would be convex, triangle, and this one would be convex as well. All right. These are regular polygons because this side, this side, this side, this side, all of these are congruent. A square is a regular polygon. This pentagon is regular because all the sides are congruent, etc. Not polygons is if there's an intersection point, if there's anything but straight segments, or if they're not connected. Those would be the reasons why they're not polygons. Now, you've probably heard of these before. Pentagon, 5-sided, hexagon, 6, heptagon, 7, octagon, 8, and then anything above that, we call it an n-gon. In other words, if it has 9 sides, you call it a 9-gon. If it has 10 sides, we're going to call it a 10-gon. 11 sides, 11-gon, etc. So, on your homework, it'll ask you to identify and classify polygons. So in this case, it's saying, tell whether the figure is a polygon. So does it fall under this criteria, or is it one of these cases where it's not a polygon? So for this one, for A, that is a polygon, and because it has 6 sides, not are all congruent, so it's not a regular polygon, but we are going to call it a hexagon. And because I can't draw to get from here to here, to get to all the vertices, I have to stay within the shape. I have to stay within the polygon. So this is going to be considered a convex polygon. Okay, now this one, it has 1, 2, 3, 4, 5, 6, 7, 8 sides. However, this doesn't count because it's a curve. So this is not a polygon. And we're going to say curved segments. Can't have curved segments. Quadrilaterals. So here's some examples. Again, you can pause the video and read these entirely for yourself. But yeah, trapezoid. Key here is that it has 2 sides that are parallel to each other, and then the other 2 doesn't have to be anything special with them. Parallelogram means 2 pairs are parallel to each other, not just one like the trapezoid. A rhombus, all four are congruent. All four sides are congruent. And it's also a parallelogram, so that means this is parallel to this, and this side is parallel to this side. A rectangle, as you've probably seen before, 90 degrees, and not all four sides have to be equal, whereas a square is 90 degrees and all four sides are equal. So we're going to classify these based on their measurements. So on this one, notice this is parallel to this. So this is what and these sides are not parallel. So we're going to just call this a trapezoid. Trapezoid. And we're going to say because it has one pair of parallel sides. Now if it had two, it'd be a parallelogram, or it could be some more specific one like this. Parallel, and these are parallel. So it's already a parallelogram. However, this is a special one because notice they are all 6. So if it's a parallelogram and all the sides are equal, that's going to be called a rhombus. We're going to say 2 pairs of parallel sides and 4 congruent sides. That's what makes that a rhombus. Finding an unknown angle measure. So remember with triangles, all the angles add up to what? 180. In a quadrilateral, they all add up to 360. So if I take this angle, this angle, this angle, and this angle, and add them all together, I know for a fact, because it's a quadrilateral, it will add up to 360. So let's go ahead and write that out. So it's going to be x plus 5 plus 125 plus 90 all together equals 360. So when I add this all up, I'm going to combine the like terms. So x and x gets me 2x, and 5 plus 125 plus 90 is 220. Okay, so right now it looks like this. So go back to solving, trying to get x by itself. Remember, whenever we solve, we're doing reverse order of operations. So first we got to look to, because we're going this direction. So we like to add or subtract, then multiply or divide. Well, right now x is being multiplied by 2, and then it's also being added by 220. So what do we have to do first? Get rid of 220. It's being added, so we do the opposite and subtract it. Subtract 220 from both sides. That's gone. So subtract 220 from both sides. We get 2x equals 140. Now x is being multiplied, so we divide. Divide both sides by 2, and x equals 70. And now in this case, it just said find the value of x. Now if it asked us to actually find the angle measures, well, this would be 70. This would be 75, because we have to plug in. But it's only asking for x in this case. Now, last one here says tell whether the figure is a polygon. If it is, polygon, classify it. Tell whether it's convex or concave, kind of like we did earlier. So again, this is 5-sided. So is it a polygon? Yes. This one's 5-sided, so it's a pentagon. And we don't necessarily know if all of them are congruent or not, so we can't say it's a regular pentagon. We can say it's a pentagon. And because to connect the vertices, I have to stay inside of the polygon, no matter what. That makes a star, see that? This is going to be considered convex. Now this one, because of this curve, this is not a polygon at all. And that concludes 10.2. Let me know if you guys have any questions on any of that. Thanks, guys.